Okay, so in this chapter, we shift our focus from how game functions to how it looks. So until now, we concentrated on programming, but improving the game's visual appeal is also important. So the visual components of a game are made up of what we call art assets. But what exactly are art assets? Art assets refer to all visual elements in the game, which includes 3D modeling, 3D models, such as characters, props, and environment. The other art assets are textures. So textures uh, are surface details and colors applied to the models, and we have materials. Materials are how light interacts with objects, including shininess or roughness. And we have effects. Effects are like particles for fire, explosion, or weather. And we have animations. Animations are how characters or objects move and behave visually. So these art assets are essential in creating an engaging, immersive experience. Without them, games would consist of just basic shapes moving around the screen, which is visually uninteresting. So in this chapter, we'll explore how to develop and add these assets to your game, moving from blank boxes to more polished visuals. The goal is to make your game look better while understanding the basics of game art and how it integrates with the programming you've been doing. So next we'll focus on specific techniques to create and apply these art assets in Unity. Uh, so understanding art assets in game development. So first, art assets are the individual visual files in a game to create its visual appearance. So these files range from 2D images uh, to 3D models and even more complex systems like animations, particle systems. So let's break down the types of art assets. Uh, first one is uh, First one is 2D image. So as you know, 2D image is a flat image like photos or paintings, which are commonly used in 2D games or as textures in 3D games. We have 3D models. 3D models are virtual 3D objects, also called mesh objects, which are these are like sculptures in virtual space. Characters, buildings, objects are examples. Materials uh, are surface properties like color, shininess, roughness of an object. uh, like uh, like choosing the material of a sculpture like a metal, wood, or a plastic. Materials are applied to models in games. And we have animations. Animation are sequences that define how an object moves. For making characters walk, or objects bounce, or even simple movements like doors opening, the movement is predefined and independent of real time code. And the last one, we have a particle system. uh, a system that basically it's a system that controls small objects, which are particles, to create effects like fire, smoke, or explosion. uh, these are important for visual effects like in games like uh, rain, fire, sparks. So these art assets are created externally in tools like Photoshop for 2D images or Blender, Maya for 3D models, and then imported into Unity. However, materials and particle systems are often created directly within Unity. So some of the important points here is uh, materials and animation animations. These are harder to relate to real world objects, but are important to making games look more realistic. And when it comes to creating art, programmers often make rough version of art called programmer art to test functionality before final assets are available. And external softwares like Blender, Maya for 3D modeling, and Photoshop for 2D images are used to create these assets before importing them into Unity. So by understanding these asset types, you'll be able to improve your game's visual appearance, moving beyond simple shapes to more detailed and polished visuals. So next topic is whiteboxing. Uh, so whiteboxing is a process of creating basic layout of a level using simple shapes like white or gray boxes. So this is often the first step in building a level, providing a rough structure before adding details and refining the design. So it allows you to quickly create a functional, playable environment that can be tested and adjusted before spending a lot of time on detailed visual assets. So whiteboxing has two main purposes. First one is quick sketch of the level. Whiteboxing lets you create a basic sketch of your level design quickly. It's a rough draft that will be refined over time. So the visual polish will come later. So but the white box version gives you something to work with right away. And level design refers to planning and creating the layouts or levels in the game. A level designer is responsible for this process. On larger teams, level designers may focus on whiteboxing, and artists later adds detailed visuals. The other purpose of whiteboxing is making the level playable quickly. So white box level is functional even if it's not finished. This allows you to test the gameplay in the environment, like walking around the space or checking if the size of the room feels right before spending time on detailed visuals. So it's easier to adjust room sizes, layouts, and other aspects of in the early white boxing stage. If something needs to change, for example, rooms are too small, you can fix it more easily at this stage. uh, Whiteboxing also keeps the team motivated because they can start playing and testing the level early on. So it's satisfying to see before starting whiteboxing process on the Unity or on your computer. It's common to draw a floor plan for the level. So this step involves helps you plan the layout and the structure of the level before building it in 3D. So if you see in your textbook, there's a floor plan in figure 4.1, which shows a simple layout with four rooms connected by a hallway. This basic design helps guide the white boxing process when you move to Unity. So in real game, your four floor plan would likely be more detailed, including where enemies, items, or other interactive elements are located. But for this exercise, a simple plan like the one in the example is enough. So whiteboxing does not involve complex coding. Instead, you'll primarily be working with basic shapes and objects in Unity. So you basically first you create a basic geometry using Unity's primitive shapes like cubes, planes, to create walls, floors, and rooms. These will be your white boxes that define the layout of the level. And then you position and scale the objects, arrange these shapes according to your floor plan. Use Unity's tools to adjust the position, size, and size of the objects to match the desired level layout, and then test gameplay. So even though the visuals are simple, you can already add your player controller from the previous chapters, like the FPS movement, to test walking through the level and navigating rooms. So by end of the whiteboxing, you'll have a basic rough version of the level that you can play and refine. So whiteboxing is an important early step in level design that helps quickly create and test a playable environment. It provides a simple but functional layout that can be adjusted before moving on to detailed art and visuals. So next topic is laying out primitives according to the plan. So in this step, we take the floor plan drawn earlier and build the level using the blank 3D objects, which are primitives in Unity. So the process is simple and involves creating and positioning cubes to act as floors and walls in your for our scene. First, you create a floor. Go to game object, 3D object, cube. You can create a cube. This will act as a floor, and lower the Y position of the floor, so to account for the height of the cube itself, so that it sits properly on the ground. And remember to scale along X and Z axis to cover the ground area of your level based on the floor plan. And then you create walls. Repeat the same process to create walls. Use cubes again but this time you rotate and scale them to match the position and the sizes of the walls in your floor plan. Adjust the height, thickness of the walls. So for neatness, you can create a parent object, for example room, and place all the walls and floor objects as a children under the parent object. You can do this by creating an empty game object and position it to 0 0 0, and you can drag the floor and the wall objects into the hierarchy window. And then you add lighting. Add some basic lighting to your scene, and choose the light type, directional point or spot. Position the lights around your scene so that you can see it clearly. And then create a player object with the movement abilities. Use the character controller component and add the movement scripts from chapter 2 if needed, so that the player can move around and test the layout. So at this point, your level should be blocked out using simple cubes. So you can now walk around the scene using the player and test the basic structure of the level. So this is about whiteboxing, building a playable rough draft of the level using basic geometry. So some of the advanced level editing and exporting tools are, first one is Pro Builder. For more complex editing inside Unity, use Pro Builder. It's a built-in tool for level editing. You can download it from the package manager. You'll find the package manager under Windows. With a Pro Builder, you can create more advanced geometrics directly in Unity. And we have the other method is exporting geometry. So if you want to take your white box geometry into external 3D software like Maya or Blender, install FBX exporter package. You can find it in the package manager again, but you must enable preview packages. So this will allow you to export your 3D your white box layout into 3D modeling tools like Maya for further refinement and visual polish. So this process of whiteboxing ensures a functional testable layout in testable level, which is ready early on in development process, allowing for quick testing and iterative improvements. So the next topic is texturing the scenes with 2D images. So in game development, once you have a basic level structure, the next step is applying textures to enhance the visual appearance of the 3D models. 3D models. So a texture is essential 2D image that you can use to add details like color, patterns, or basic properties such as brick walls or wooden floors to 3D objects. So what is a texture? A texture is a 2D image used to improve the look of 3D graphics by covering surfaces. So it acts as a kind of a wallpaper on a 3D model, making flat, blank objects appear more realistic. For example, consider a basic cube, which is like a white boxed wall. Apply a brick wall texture. Applying a brick wall texture can make it look like a real wall. So other uses of textures include like masks to define shapes, and like normal maps to create an illusion of bumps on a surface. So so textures are typically stored as image files. So there are several types of file formats supported by Unity, each with different features like compression, transparency. So we have two key terms. Alpha channel controls the transparency of the image, which is important in 3D graphics. And we have compression. So compression is basically reduced file size that can also affect quality, which is like a lousy compression reduces image quality. So some of the recommended file formats are PNG and TGA. So PNG supports lossless compression and has a alpha channel, which is ideal for textures. And TGA is used in 3D graphics, supports lossless compression and includes a alpha channel. So both PNG and TGA are recommended because they retain high image quality and support transparency. And we have few other formats, JPG and PSD. So JPG uses lousy compression, reducing image quality, and which doesn't have alpha channel. And PSD, which is a native format for Photoshop, which is good for editing, but might not be ideal for final textures in Unity. So how to apply these textures? You basically import your texture file, which can be PNG or TGA into Unity, and then apply the textures to your 3D objects by just dragging and dropping the image onto the object in the scene. So by applying the textures, you can take your scene from a simple white box to more polished environment, making it visually appealing and realistic. So next topic is importing an image file for texturing in Unity. So to import and prepare textures in Unity, you'll first need to understand the concept of tileable images, which are crucial for creating seamless textures such as large surfaces. So let's break down the process. First is tileable image is an image whose opposite edges match perfectly when placed side by side. So this allows the image to repeat across a surface like floors or walls without visible seams, similar to how wallpapers repeat across web page web page backgrounds. So websites like www.textures.com offers many tileable images often used for 3D projects. You can find various textures like bricks, wood, metal, and many others. So for your exercise, you can download tileable textures like I think there's a like brick round and brick large bear from the website. So after downloading, you need to adjust the size and file format. So 3D textures such as should have dimensions in the powers of 2. For example, 2064 by 64, 256 by 256. So these are some dimensions. So this is because graphic cards process textures more efficiently in these sizes. Resize your image into 256 by 256 pixels using an image editor like Photoshop, GIMP. So save the file as a PNG for use in Unity, which supports transparency and is widely used in 3D projects. In Unity, you simply drag the prepared image file into the project view. So you can also right click in the project window, import new asset, and select the image file. So after importing, Unity will recognize these files as textures which are ready to be applied to 3D models. So it's a good idea to organize your project's files as they grow. Create specific folders like scripts, textures, materials. Just drag and drop these files into appropriate folders in Unity's project window. Avoid using special Unity keywords like resources, plugins, editors, gizmos for folder names, as the Unity has reserved functionality for them. So by following this process, your images will properly imported in Unity and ready to be applied as textures to enhance the visuals of your 3D scene. So this process sets the foundation for creating visually rich environment in your game. So the last topic for today is applying textures to objects in Unity. So textures are not applied directly to 3D objects. Instead, they are part of materials which are applied to geometry. So let's go step by step. First, textures and materials. So a material defines the surface properties of an object, including textures. So the texture is a part of a material settings called albedo for base color, and then you drag and drop. You can drag the texture from the project view directly onto the object in the scene view. So Unity will automatically create a material for that object using the texture. So try this with a floor texture. Drag the texture onto the floor object, and Unity will handle the rest. And for more controlled process, you can create material manually. When you go to assets, create material, a new material will appear in the project view. Select the material, and you'll see a slot for albedo, which is a base color, and drag the texture into the albedo slot. So when you drag the material from the project view onto the object in the scene view, try this with a wall texture, and create a material, add the texture, and then drag the material onto the wall object. So when you apply the texture, it may look blurry because the texture is stretched to cover the entire surface. So to fix this, adjust the tiling property of the material in the inspector. Set the tiling values x and y to control how many times the texture repeats across the surface. So for example, tiling to 8 by 8 to repeat the texture multiple times, making it look less stretched. So now where the floor and the walls uh, will have a properly applied textures, enhancing overall visual quality of the scene. So this method is useful for white box geometry, but in polished games, advanced 3D tools are used for more complex texturing setups. So by following this process, you can add realistic textures in your to your game environment, improving both visual appeal and gameplay immersion.